All right, guys. So we are going to um, get into the fourth video here for chapter 15, which is finding the right statistics for your data. This is really going to come in handy for you guys with your research proposal and trying to figure out what statistics are most appropriate for whatever study you're proposing. And there's lots of flow charts that we're going to help you on that process. I really like the way this is presented because it's very helpful for you guys is as far as visually and conceptually helping you guys make sense of really all the information you've learned in this textbook, combining it all and showing how it all fits together to get to those results from these studies. So we're going to talk about learning objective number 10, which is identifying characteristics that differentiate the different sets of data, and identifying the hypothesis tests that are appropriate for each of those data structures. Remember, all the way back in chapter 6, we talked about how the five basic research strategies produce 3 distinct data structures. And so we're going to skip this slide and we're going to come back to it. So there's 3 basic data structures. We have category 1, which is descriptive only, right? There's one group of participants, there's one variable you're measuring per participant, and your goal is just to describe. We just talked about that in chapter 13, okay? There's also the second category, which is correlational research, which is where there's one group of participants and there's 2 or more variables measured for each. Usually it's just 2, but there could be more. And so you're measuring both variables you're interested in. So you're looking for a relationship, you're measuring both variables. That's key. The key difference between category 2 and category 3 is that you are measuring both variables. And we talked about that in chapter 12. And then category 3 includes experimental, non-experimental, and quasi-experimental strategies. And that's when you are putting them in groups. This is where the groups come in. This is where one of the variables is being defined by groups, or you're using that variable to define groups, 2 or more groups of scores. And there is a measure, the second variable is being measured by each. I don't really like the way that's worded, so I'm saying it in my own way. The second variable is being measured in order to use that to compare the 2 or more groups of the first variable. So again, first variable is divided into groups, the second variable is being measured. We talked about that in chapters 7, 8, 9, 10, and 11, because there's lots of different ways to do all of that. So before we move on to the flow charts and all of that and going deeper into those categories, I want to remind you of the scales of measurement, because it's been a while since we've talked about it in depth. It was all the way back in chapter 3. We have referenced it a few times, but I want to remind you guys that in addition to those categories that we have to, that helps determine what statistics we use and how we evaluate our hypothesis, you also have to use, or you should pay attention to the scales of measurement. That also helps determine what statistics you can use and what hypothesis tests you can use. So, as a quick review, ratio scales and interval scales are often grouped together because they are those numerical scores that are compatible with mathematical equations and calculations, right? So that's the examples of that is like height in inches, weight in pounds, the number of errors performed on a task, IQ scores. They're numbers that you can do math with, basically, okay? Ordinal scales are ranks. Those are those things like small, medium, large, or first, second, third. Those are those categories that are ranked. When you see ordinal, think order, think rank. They're in order, okay? So the math that you can do with those is not the same as the math you can do with just plain numbers, right? There's very limited math you can do with that. And then also there's nominal scales, which is not numerical in any way, shape, or form. Those are those names, those labels, those labeled categories or names, nominal, think name. The examples of that is eye color, academic major, occupation, political affiliation, whatever, okay? Those are those named categories, okay? And so that's going to help determine what we use to figure out our results. So category 1, remember, is that the intention, the goal is to describe individual variables, right? It's all about description, not comparison, not relationships, just describing. It's one variable we're looking at and we're describing it. So the most common used statistical procedure is obviously descriptive statistics, because that's the goal of descriptive statistics, is just to describe. There are some limited situations where you could have a basis for a null hypothesis and you could do a hypothesis test. That's going to be situations where there's like a neutral score, but those are rare, so we're not going to get super into that. But just know that that can occur. There's 3 types of data that you can get from this category, from category 1. There's the, again, interval ratio scales, those numerical. There's the ordinal. B here is the ordinal or ranked categories, and then C is the nominal. So you can see in column A here, number of text messages, that's numerical. That is that ratio or interval data. B here is the ranks. It's the high school rank. Okay, their rank in their graduating class. And then C here is whether they got a flu shot last season. It's just yes or no. So that is a nominal category. That's a name, right? It's not numerical. So what do we do with this? If we go back, so here is the flow chart for category 1 data. This is figure 15.12. You can see down there at the bottom from your book. The words are a little bit bigger in your book. I'll show you really quickly. You can see those a little bit better, but I'm not sure if it's going to cut off this chart in the video when I post it. So I'm going to use this, but just know if you can't really read that very well, view it in your textbook, and the font is definitely bigger there. So basically, this first column here is where you are deciding your type of data, right? You have to look at your data and what type did I use. If I have numerical scores, then you can move on to either, you can see the second column is descriptive statistics. You can move either to mean and standard deviation or proportions or percentages to describe the distribution across categories. If you have ordinal scores or those rank scores, then you have to use the median for your descriptive statistics. And if you have nominal scores or those named categories, you have to use the mode, which we talked about this before, for descriptive statistics. There could be inferential statistics, again, if you can do that reasonable hypothesis. That doesn't usually happen. You can see mostly it's chi-square test has to be used. You could use a single sample t-test. But again, because this isn't really, you're not really comparing here, it's just descriptive, that doesn't usually happen. It's usually just these descriptive statistics column here. So that shows you for category 1. Now, category 2, remember the goal is to describe and evaluate relationships. Okay, typically it's 2 at a time, 2 variables at a time, but it's relationships. Remember, we're measuring 2 variables. There's no groups. We're measuring 2 variables, and then we're seeing how those 2 variables relate to each other, how those 2 measurements relate to each other. The most commonly used statistics, obviously, are correlation and regression here, which we talked about in the last chapter, I believe, or maybe it was the one before. But the alternative statistic for the non-numerical is the chi-square test for independence. And so remember, here is where we're just observing and recording data. There's not usually any kind of manipulation or control. It's usually just observing and measuring 2 variables. So there's 2 types of data that you can get from category 2, or 4 basic categories. The numerical scores for each set, so both variables are numerical. In B here, they ranked the scores, gosh, from both variables. I'm sorry, my brain. And so that's the ranked data for both variables. And then for C, numerical scores are for one variable and nominal scores for the second variable. And then for D, both variables are nominal. Okay, so 15.6 here shows you what that was talking about. So for this one, it's SAT scores and GPA. Obviously, those are both numerical, right? B is where there is ranks. So really all they did was ranked the scores from here is what they did to get this. But these are ranks. So that is that ordinal data where both are ordinal. Okay. And then here in C, we have age, which is numerical, but then we have wristwatch preference, which is digital or analog. And so that is nominal, obviously. So we have one numerical and one nominal. And then D here, we have both nominal categories, or both variables are nominal. Okay, we have liberal, conservative, and then we have their academic major. So for these numerical, when you have to do that chi-square test, you would have a matrix of categories of the two variables. So you see on the vertical column here, you have conservative and liberal, and then your other variable is along the top there, the academic majors up there. And what you would do is put the frequency, this is like a frequency distribution matrix. You would put the frequency of how many people were arts majors that were conservative. You'd put that in that first box. And then underneath that, you would put how many arts majors were liberal. And then you would just follow that and you would put the frequency. And that matrix, that frequency matrix, is what would help you determine with that chi-square test whether there was a significant difference between those two. I mean, not a significant difference. My goodness, my brain is crazy. We're talking about correlations. Whether there is a correlation between those two variables. The hypothesis test for all of these types, for this category 2 data, the hypothesis test would be that the null hypothesis. If you remember that from the last video, the null hypothesis would be that no relationship exists. Okay. So since we're talking about correlations, the null would predict that there's no relationship, right? Because your research hypothesis would be that there is a relationship. So the flow chart for category 2 data is right here. And I don't know that I can get all of that in. So I think we're going to try and see if we can get it more in this one. Hopefully you guys can see all of this. This is figure 15.13, obviously. And so you see this first category, again, is your type of data, okay? You have to look at that first, okay, and then go from there. So if both variables are measured with numerical scores, then you see that's that first box. You can move on to one of either for descriptive statistics, either the Pearson correlation or the regression equation, okay? If we're going down this type of data column, if both variables are measured on ordinal scales, they're both ranked, then you have to use the Spearman correlation. If numerical scores for one variable and then the other one is a nominal variable, so it's ranked 0 or 1, or coded, rather, not ranked, sorry, coded as 0 or 1, like yes or no, or digital or analog, like we saw in that data set above, then you can use a point by serial correlation. If both variables are nominal and you have to code them as 0 or 1, then you use the phi coefficient to describe the strength of the relationship. And then with any measurement scales, with a small number of categories for each variable, again, if you're going to use that chi-square, you have to make that matrix we talked about, regroup that data as a frequency distribution matrix in order to use the chi-square. So there's your descriptive. And then again, going on to the inferential for numerical scores, it's going to be either a t-test or that regression. If both are ordinal or ranked, then you have to use a advanced statistical procedure, which we're not going to talk about here. So that's why it says consult an advanced statistical test. There's a lot of other options there. If one is numerical and one is nominal, It can be listed as two groups suitable for a t-test, and there's other ways you could do that as well. Again, more advanced statistical texts. And then if they're both nominal, they can be evaluated using a 2x2 chi-square test for independence. And if you're going to regroup it and do that chi-square, you can do that for really any measurement scales. That's what that bottom one is saying. So that is for category 2 data. So what about then category 3, which is the one we've talked about the most in chapters 7, 8, 9, 10, and 11, which is talking about where we're using one variable to define groups, and then the second variable is the one we measure, where we have our independent and our dependent, or our quasi-independent and our dependent variable. So this is reminding you right here is that one variable that defines the groups, it could be 3 different kinds. It could be a participant characteristic like age, race, whatever. It could be a time variable where you have like before and after treatment, or it could be treatment conditions where you have caffeine and no caffeine condition, or you have, whatever you guys have we talked about all kinds of different treatment conditions. But that's what's defining the groups. It could be one of those 3 things. And then we're comparing the groups based on the measurement of that second variable, that dependent variable. Also, as a reminder, there is between subjects and within subjects here as well, meaning that you can have that between subjects or independent measures design where it's a separate group of participants for each that are in each group. And so your book uses the example of comparing scores for liberals and conservatives. Obviously, you have to have 2 different groups of participants. The within subjects is where we are using the same participants in both groups. We're repeatedly measuring them, so it's also known as repeated measures. And so the common example of that is that non-experimental pre-post study where we are measuring a group of participants before treatment and then after treatment. So they're being measured twice, before and after. So that's within subjects design. That also is going to determine how we what tests we use. And so that's why we are reviewing that quickly. So the examples of data here. So this first example is quiz scores for students taking notes longhand or on a laptop, meaning they wrote it out or they did it on a laptop, how they took their notes. And then their quiz scores. So we're comparing those 2 groups. So this is obviously numerical scores. These are quiz scores, right? So we would probably use a one-way ANOVA or a t-test for that. It could be independent measures or repeated measures. Here it would be independent measures because it's a between subjects design, because there's different students in the laptop group versus the students in the longhand group, right? They either took notes on a laptop or longhand. They didn't do both. Although you could structure a study to do that, but that's not what that is talking about there. This one is performance scores before and after 24 hours of sleep deprivation. So again, this is a within subjects because they had the same participant. You see the participant A, B, C. They measured them before they had been sleep deprived for 24 hours and then after being sleep deprived for 24 hours. So these are still numbers. So we would still use the one-way ANOVA or the t-test, but this would be a repeated measures ANOVA or a repeated measures t-test because of the within subjects design. This data set is where it is all nominal. So this is success or failure. They either succeeded or they failed on a task. And the 2 groups are, did they work alone or did they work in a group? Excuse me, my voice just went away for a second. So did they work alone or did they work in a group? We're comparing those 2 on fail or succeed. So this is that nominal data, the data that would have to be coded 0, 1. And for that kind, we would have to use a chi-square test of independence with that matrix of frequency distribution that we talked about. And then this one is the amount of time spent on Snapchat, either a small amount of time, a medium amount of time, or a large amount of time. So this is this is ordinal data, right? This is that ranked data. And they are comparing each class, freshman, sophomore, junior, and senior on this. And so this is that ordinal data. So that's just the different types, small example of the different types of data that you can have with these kind of designs. Really, let's see, hold on. There's those matrices we talked, or those matrices we talked about for the chi-square test, where they would have success or failure, work alone, work in a group, and you'd put the frequency in those blank spots. Or this one with the Snapchat, small, medium, or large, and then you have freshman, sophomore, junior, senior, and you could do the frequency distribution and do the chi-square for that. Your book also wants to point out that you also have to consider two-factor designs. All the ones we talked about up to this point are single factor, meaning there was only one independent or quasi-independent variable, right? There was only one variable that was defining groups, or that was defining the groups we were comparing. As we talked about before with factorial designs, you can have two-factor or three-factor or whatever. You can have as many independent variables as you want. And this is reminding you of that is also a possibility, and that for that you would use the two-factor ANOVA or two-way ANOVA. Again, you have to develop that matrix, not a frequency distribution matrix, but the matrix of the means for each combination of groups, where the levels of one factor defines the rows and the levels of the other variable defines the columns, and then the measurements of the dependent variable is what goes in the boxes of the matrix. And then we compute the mean and the standard deviation, of course, and we would use either the two-factor ANOVA or two-way ANOVA to evaluate whether there's a significant difference between the means of each of those cells. Because you have to have cells now, because we have two different groups or two different variables defining groups. So there's a lot more groups to consider, right? So here is the flow chart for that one. Again, I'm doing it on here because I think that the cells here are going to be, or I mean well, they kind of are cells, but the boxes here will be easier to read. But really quickly, I did want to show you, I forgot to go back because we were looking at the textbook. I forgot to go back and show you guys the slides for what I was talking about, but that this is for numerical scores, the one-way ANOVA or the t-tests, the normal or ordinal scales use the chi-square, and the two-factor design with interval or ratio scales is that two-way ANOVA. And then this is what I was just talking about with the two-factor designs with the scores from interval or ratio scales, where it's kind of walking you through that process. But we talked about this when we talked about factorial design, so this is really kind of just a review of that process. And then there's the flow chart, but we're going to go to this one instead so you guys can see it better. This first column, notice, is the data type. Again, is it ratio? Is it interval? Is it numerical? Or is it ranked ordinal data? Or is it nominal data? Or is it a factorial design with the interval ratio scale? Okay, so that's the three things there. The second, or four things, I guess I should say, the second column there is you have to ask yourself, okay, how many groups do I have? Do I just have two groups I'm comparing, or do I have more? And that helps determine which way you go from there. The third column is whether it's between subjects or within subjects design. So remember, independent measures is the between subjects design, and repeated measures is the within subjects design. So if there's separate people in each category, in each group, then it's independent measures. Are the same participants in both groups, they're being measured more than once, that's repeated measures, okay? And then ultimately, finally, you get to the fourth column where you actually get to the descriptive statistics you would use for each of those situations, and then the inferential tests or statistics that you would use for each of those situations. And I kind of already talked about this a little bit, but you can see mostly you would use the mean or standard deviation for all the numerical ones, and then for the ordinal data, Regardless of any other thing, you would use the median or the proportion. And for purely nominal data, you would use the proportion in each category for the descriptives. Inferential is where it changes. The inferential statistics is going to be different for each of these scenarios. So t-tests are used when it's when there's only two groups of a single factor design. It'll be independent or repeated measures depending on whether it's between or within subjects, obviously. The ANOVA is used when there's more than two groups that you're comparing. So it'd be, and again, it would be either independent or repeated measures depending on how your groups are laid out. The ordinal data, and I'm just going down this column of inferential statistics. The ordinal data is, again, going to be an advanced statistics textbook. And then the nominal data, as always, chi-square test. And then the factorial designs, if it's 2-factor or 3-factor or whatever, if there's more than one independent variable, you're going to have to use that factorial ANOVA that we talked about a few chapters ago. So that is it, I believe, for all of the flowcharts. So you've now learned about all the 3 categories and what we do with it. And this is part of the reason why it's so important for you to understand each of the chapters and topics before we move on, because you see here, we put all of that together. And if you never really understood what those scales of measurement were, or if you never really understood between and within subjects, or if you never really understood descriptive, correlational, and experimental, if you never really understood the difference between all those things, then those flow charts probably made you nauseous and you didn't understand any of that at all. And so I hope that's not the case. I hope that you guys, that at least that's made somewhat a little bit of sense to you guys. But again, if there's any questions about any of that at this point, now that we're reaching the end here, please don't hesitate to email me and let me know. So our knowledge check for our slides here is, what are the 3 scales of measurement? Remember, those are ratio scales, interval scales. That's the numerical ones that you can do math with. Ordinal scales is the ranks, and then nominal is the named or labeled categories with words, not numbers. And then we have our learning check really quickly. One category of data is obtained, so one category, by measuring one variable, and it's just a single group of participants. So what kind of statistics are we going to use? So it's just one variable, one group of participants. There's no comparison, there's no relationship, it's one variable. So that has to be descriptive, right? There's nothing to compare, there's no relationship, it's just one variable measured. So it's descriptive statistics. Now this one category of data is obtained by measuring 2 different variables, all right? So we got 2 different variables. For each individual, single group of participants, what kind of statistics are we going to use for that? So it's 2 different variables. So we're going to compare. Are we comparing these variables, or are we looking for a relationship? Are there groups, or is there a single group? It says there's a single group. So we're not comparing groups. There's just a single group of participants. And there's 2 different variables we're measuring. We're measuring 2 different variables. So that is going to be those correlations, right? Because we're measuring 2 different variables. We're not using one to define any groups. It's just a single group of participants measuring 2 variables. We're seeing if they're related. That's correlations, or chi-square tests if it's not numerical data. For a between subjects study, so right there, we know that we're comparing groups because it's a between subject study. We're evaluating the mean differences among 3 different treatment conditions. Which of the following is the appropriate hypothesis test? So again, we have a between subjects design. So the participants are different. They're independent in each group. There's 3 treatment conditions. So there's 3 groups. So we can't use a t-test automatically because there's more than 2 groups. There's 3 groups here. So that means we have to use an ANOVA. And remember, ANOVA, I don't know if you guys remember, stands for analysis of variance. So that's what this is. There's only one independent variable here, so it's single factor analysis of variance, right? It's not a factorial design. There's not that the thing where we have to do the crazy matrix and all that. To show you how I got there, if I walked through that and you were like, what? For that third question, I just walked through this flow chart essentially in my mind. So we know that it's a single factor because it said there was only one variable and there was three groups. So we know that it's this single factor right here, numerical scores. And then we know it was either, or we know that it was more than two groups, right? There's two or more groups. We have to go down to that two or more groups because we know there's three groups. It said it was between subjects, so that means we have to go up to the independent measures box. And then we go over all the way to inferential statistics and see that it says independent measures ANOVA is what we would use. And so you see, if we go back down, it was a single factor analysis of variance. It didn't actually say, this doesn't actually say independent measures ANOVA, but that's what it would be. But it just didn't get as specific. They threw the independent measures t-test in there, I think, to throw you off, because when you see between subjects, you automatically think independent measures. And so they probably threw that in there to see if you would select t-test just because of the independent measures. And it would be independent measures t-test if there was only two conditions or two groups. But since there's three, we have to do the ANOVA. So that is it for 15.4. And if you guys have any questions, I'm here.